Hey everyone, and welcome to this digital notebook journey. Today, we are going to completely master Chapter 3 of your Class 10 Science syllabus, Metals and Non-Metals. आज हम इस chapter के हर एक important concept को clear करेंगे so that you are 100% ready for your board exams. So grab your mental highlighters and let's dive right into this. Here is our roadmap for today. First, we'll cover metals versus non-metals basics. Second, chemical reactions unlocked. Third, the Reactivity Series. Fourth, Ionic Bonds and Compounds. Fifth, Extraction and Metallurgy. And finally, Corrosion and Alloys. Let's get to it. Starting with Section 1, Metals versus Non-Metals Basics. Now, take a look at the physical world around you. We can pretty clearly separate elements into two distinct categories. Metals are generally hard, malleable, and good conductors. यानी धातुएं सामान्यतः कठोर, तन्य तथा विद्युत की अच्छी चालक होती हैं. Malleability simply means you can beat them into thin sheets without them snapping. And ductility? Well, that's the ability to draw them into incredibly thin wires. Listen to this. Did you know you can get a 2-kilometer-long wire from just 1 single gram of gold? Literally mind-blowing. On the flip side, non-metals are brittle, non-sonorous, which just means they don't ring when you hit them, and they usually have a pretty dull appearance. You've definitely seen this classic NCERT experiment before. When we place a piece of metal between the clips, the circuit is completed, and boom, the bulb glows. क्यों? क्योंकि metals electricity को freely flow करने देते हैं. They're like a massive open highway for electrons. This is exactly why we use metals like copper and aluminum for all the electrical wiring in our homes.
Alright, sit up and pay close attention here. This is a massive exam alert. The board examiners absolutely love, and I mean love, testing you on these exceptions. We just said metals are solid, right? Well, mercury is actually a liquid metal at room temperature. We said non-metals are bad conductors, but graphite conducts electricity beautifully. Iodine is a non-metal, but it's lustrous, meaning it's really shiny. And while metals are famously hard, alkali metals like sodium and potassium are so soft you can literally slice them with a butter knife. इन exceptions को अपने दिमाग में mentally highlight कर लीजिए. They are guaranteed tricky questions for your exams.
Moving right along to Section 2, Chemical Reactions Unlocked. Okay, so we are transitioning from what we can see physically to the invisible, fascinating world of chemistry. How do these elements behave when they meet air, water, or acids? The absolutely crucial point here is that not all metals react the same way. Think of this list like a sliding scale of chemical anger. Potassium and sodium are so incredibly furious they react violently even with cold water. इन्हें kerosene में डालकर रखा पड़ता है. Otherwise, they literally catch fire just sitting out in the open air. Magnesium is a bit more relaxed, needing hot water to get going. Aluminum, iron, and zinc, they only react with steam. And down at the bottom, lead, copper, silver, and gold, they just don't react with water at all, completely unbothered.
Now, I really want you to draw a giant star next to this definition in your notes. Amphoteric oxides. Usually, metal oxides are basic in nature, but amphoteric oxides, these are the chemical rule breakers. They react with both acids and bases to form salt and water. The absolute classic examiners your examiner wants to see are aluminium oxide and zinc oxide. ये NCERT का all-time favorite question है, so please do not skip it.
All right, let's jump to Section 3, the Reactivity Series.
This series right here, this is your ultimate cheat code for predicting chemical reactions in the exam. At the very top, we have the highly reactive divas, potassium, sodium, calcium. They want to react with absolutely everything they touch. In the middle, we have our moderately reactive, kind of middle ground metals, like magnesium, zinc, and iron. And down at the bottom, the low reactivity, chill, completely unbothered noble metals like gold and silver. ऊपर से नीचे आते हुए reactivity कम होती जाती है. It's that simple. And see how perfectly this builds into our next concept, displacement reactions. Because we know the reactivity series now, we automatically know that a stronger, more reactive metal can just kick out a weaker one. ज़्यादा ताकतवर metal कमजोर metal को उसके compound से निकाल फेंकता है. For example, zinc is placed above copper in our series. So zinc is strong enough to literally bully copper out of copper sulfate, taking the sulfate for itself and leaving poor copper all alone. That's chemistry in action.
Let's slide into Section 4, Ionic Bonds and Compounds. So we've seen how metals and nonmetals differ, but how do they actually resolve their differences and join forces? Well, they do it through ionic bonds. Metals have extra electrons they desperately want to get rid of, so they lose them and become positively charged cations. Nonmetals, on the other hand, need electrons, so they happily snatch them up and become negatively charged anions. And as we know, opposites attract. This creates a massive electrostatic force pulling them together. Take sodium chloride, our everyday common table salt. Sodium becomes positive, chlorine becomes negative, and they lock together tightly. ये bond इतना strong होता है that ionic compounds are almost always solid crystals with very high melting and boiling points. But here is a sneaky trick question they might throw at you in the exam. Can salt conduct electricity? Well, it entirely depends on its state. Solid ionic compounds have their ions locked tightly in place, almost frozen, so no electricity can flow. But if you melt them or dissolve them in water, which is called the aqueous state, the ions finally break free. जब ions free move कर सकते हैं, तभी electricity conduct होती है. So salt water easily carries a current, but solid salt, not a chance. Moving to section 5, extraction and metallurgy. Okay, so we know all about these elements on a micro level now, but let's zoom out to the macro scale. How do we actually pull these metals out of the massive Earth's crust, from ores and gangue, which is just a fancy word for earthy impurities? The extraction method completely depends on that cheat code we learned earlier, the reactivity series. Metals at the very top are too strongly bonded. They need a heavy-duty, intense process called electrolysis. The ones in the middle can be extracted using carbon reduction, and the ones at the bottom, because they are so chemically lazy, they're often just found lying around in nature in their free state. Now, instead of getting lost in those dense, boring textbook paragraphs, I want you to just memorize this easy, energetic 4-step checklist. Step 1, crush and grind the big rocks of ore. Just smash them up. Step 2, concentration, यानी मिट्टी or impurities. जिसे हम gangue कहते हैं, उसको हटाना. Getting rid of the junk. Step 3, extraction, where we chemically convert the concentrated ore into a crude metal. And finally, step 4, refining, to purify that crude metal into something shiny and perfectly pure that we can actually use. Boom! That is metallurgy simplified. Time for another exam alert. Step 3 of extraction has 2 terms that almost always confuse students: calcination and roasting. The absolutely key difference you need to remember here is the air supply. Calcination is for carbonate ores and is done in strictly limited air. Roasting, on the other hand, is for sulfide ores and is done in excess air, kind of like roasting marshmallows over a big open fire. Keep that one distinction crystal clear and you'll easily secure those marks. And finally, section 6, corrosion and alloys. We did all this incredibly hard work to extract the metals, but how do they actually survive in the harsh, real world once they are out? Metals, unfortunately, hate moisture and air. It causes corrosion, like the familiar rusting of iron. To protect them, we can use really simple methods like painting or oiling the surface. But a genuinely fascinating industrial method is galvanization. Galvanization का मतलब है iron को zinc की एक protective raincoat पहना देना. The zinc takes all the chemical damage from the environment instead of the iron. Another brilliant survival technique is creating alloys, which is simply a homogeneous mixture of metals designed to radically improve their properties, like mixing soft iron with a bit of carbon to create incredibly tough structural steel. And that brings us to the very end of our digital notebook journey today. But I want to leave you with a question to really get you thinking. If gold and silver are at the very bottom of the reactivity series, how does this chemical laziness, the fact that they just stubbornly refuse to react with air or water, make them the absolute perfect choice for jewelry that lasts for generations? Think about how this abstract textbook chemistry ties directly into your everyday lives and the very things we wear. All the best for your board exam, students. Keep studying, keep shining, and always keep asking questions.